In this video, we're going to practice finding products when the indexes of roots don't match. Let me give you an example. So here I'm supposed to simplify, and in the past we've just multiplied the radicands together. But we can only do that when the indexes match. For example, these would both have to be square roots or both have to be cube roots. But in this case, they're mixed. We have one square root and one cube root. In order to still find the product, I'm going to switch from roots to rational exponents. My first factor is going to be a base of 5 with an exponent of a half, and my second will be a base of 5 with an exponent of 2/3. Since bases are the same and I'm multiplying, I can now add the exponents. I'm going to need a common denominator since I'm adding fractions, and I hope you can see that that's going to be 6. For the first fraction, I'll need to multiply both the numerator and denominator by 3, and for the second, I'll have to multiply the numerator and denominator by 2. When I do that, I'll get 3/6 plus 4/6. That adds to 7/6, and then we usually write our final answers as a root, so we go back to roots, and this is going to be the 6th root of 5 to the 7th. Last, I notice if I divide 6 into 7, one factor of 5 will get out, and one factor will remain inside, since when I divide 6 into 7, I get a remainder of 1. Try this one. My first factor will have a base of 2 and an exponent of a third. My second will have a base of 2 and an exponent of 3/4. Now, since bases are the same and I'm multiplying, I can add the exponents. To add the fractions, I'll need a least common denominator, which will be 12. For my first fraction, I'll multiply by 4/4, and for the second, I'll use 3/3. Now I can add and get 13/12. Once I write back to radical form, I notice 12 divides 13 once, so one factor of 2 will get out with a remainder of 1, so one factor of 2 will be in the radican. How about this one? First, I'll rewrite into rational exponents. The first factor will have an exponent of a half, and the second an exponent of a third. Since my bases match and I'm multiplying, I can add the exponents. My least common denominator will be 6. For the first fraction, I'll use 3/3, and for the second, 2/2. I can now add and get 5/6. And when I write back to radical form, this will be the 6th root of x to the 5th. How about here? My first factor will have a base of 2 and an exponent of 7/3. The second will have a base of 2 and an exponent of 4/6. Now I could move forward and use a least common denominator of 6. That would be fine. But I just want to mention that you could also reduce and get 2/3 here, and then I'd have a common denominator of 3. Either approach is fine. Now that the bases are the same, I'm going to add the exponents. This will give me 9/3. 9 divided by 3, of course, is 3, and so I end up with 8. Try this one. I'll write both factors with rational exponents. Now here I notice that I could reduce this to 2/3, and that would be fine, but I also notice that I'm going to end up with an LCD of 12, so it just seems easier to me to keep the common base and add the exponents, and then go directly to a least common denominator of 12. I'm going to multiply the first fraction by 2/2, and the second by 3/3. Now when I add, I'll get 17/12. I'll write back to radical form. Then 12 goes into 17 once, so 1 factor of y will be outside with a remainder of 5, and so that will be the exponent on the base of y in the radicand. Here's another. After rewriting with rational exponents and adding the exponents, we see that the least common denominator would be 9. I'll only need to multiply the first fraction by 3 over 3. Then I'll be able to add the numerators and rewrite back into radical form. And here's our last one. I'll rewrite with rational exponents. Then, keeping the common base, I'll add the exponents using the product property. I can see that my least common denominator should be a 15. I'll need to multiply the first fraction by 5 over 5 and the second by 3 over 3. Now that I have a common denominator, I can add the numerators, and then I'll write my expression back into radical form. Well, that'll conclude this video where we found some products when our indexes on our roots didn't match.